So, let us start with the combiner. The combiner, yes, you need to understand what is a combiner. So, now you can say what happens in the map reduce. Let me summarize few of the points. So, what happens actually, the mapper, just to understand, the mapper produces a large amount of, you can say, intermediate data. You can say intermediate data, right, and which is your passed to reducer for, like you can say, for processing, right. So, this is the map reduce do that. So, what happen in this, which can results when you produce lots of data, what it can results in lots of your network congestion, because when the lots of data is producing by the map reducer and the mapper part, and then mapper will transfer this data to the reducer, what will happen, lot of data will be generated and lot of network congestion. So, let us say when you do the word count problem, let us say one word is coming, let us say cat is coming to 10,000 times, similarly bat is coming 5,000 times, right. So, similarly lots of words are coming lots of time, because you have very big paragraph. So, what happens, the whole 10,000 cats will move to one reducer, similarly 5,000 bat will move to the another reducer, or might be in the same reducer. Similarly, lots of words are there, lots of data is there, then means it need to travel the data, then lots of network congestion is there, right. So, now what happens in this scenario, the combiner will play a key role, in reducing this kind of network congestion. So, now this is the opportunity for the combiner to reduce the network congestion. How it is possible, let us see. So, that is why it is sometimes also called as a mini reducer. It is also called a mini reducer. So, what actually combiner do, it is combine, I will show you the diagram from the diagram perspective. It combine, or you can say summarize, combiner actually summarize the mapper output. Try to understand what I am trying to say is, so summarize the mapper output records, and with the same key, it is not changing the key. So, with the same key it will summarize this, what it do, by passing to the reducer. Now, try to understand, let us say in the different mapper I have 10,000 cat, and let us say I have 5 reducer and 2 reducer and 5 mapper. In all the 5 reducer, total number of cat is coming 10,000. Let us say in one mapper there are 2,000 cat instances coming, in another 4,000 is coming, in another 4,000 3,000 is coming, and the last one is only 500 is coming, and the fifth one it is only 500 is coming. Okay. So, now what happens, I will just draw the diagram also. So, what happens, instead of transferring the whole data together, combiner can also do the reduce part. So, what the reducer will do, reducer will aggregate the cat and it will say, okay, cat comma 10,000. So, instead of doing the reduce part in the reducer end, because we need to travel lots of data, at the combiner, at the mapper part, combiner will do some kind of a summarization. So, let us say in the first 4,000 cats are there, so it will summarize there only, and it will generate the output like cat comma 4,000. So, that means it is saving 3,999 instance of cat just to transfer. So, that means it is saving lots of data. And similarly, in other mapper it will try to summarize, and total how many cat instance will travel, only 5 will travel with the value, let us say cat comma 3000, cat comma 4000, cat comma 1000, cat comma 500, cat comma 500, only 5 instance will travel, and then the job of the reducer will be very easy. That is why it is called a mini reducer. I will show you in the diagram also. Okay. So, just I hope high level you understood this. So, now you can say that primary job is just to process, primary job of the combiner is just to process the output data, right, the process the output data from the mapper, or we can say mapper function, and before passing it to the reducer. So, it will summarize before passing into that. Now, you can say that this combiner and reducer sometimes are identical. The combiner and reducers are sometime identical, right. So, sometime identical, and just we need to understand when they are identical, their possibility. So, let us understand one by one. Why? Because it implement these classes are implements reduce interface, right? Both are actually implementing the reducer interface, right? And they give the new implementation to the reduced method. Okay, so that means both are same, because they are implementing same reducer interface and then they are overriding the method called reduce. Okay, and it is also possible that combiner and reducer are same, only possible only if you can say operations performed in both the reducer and whatever the operation they are going to perform either in the reducer or combiner is actually commutative and associative. Okay, this is very important. If they are functions and operations are associative and commutative, then they can be identical, right? So we are going to understand this part also later. Give me a moment. Now you can also say that now input and the output, the input and output of the combiner and you can say reducer must be identical. So in that scenario we can say that these are having the same functionality. Okay, so just to add a few more points on the combiner part, you can say that this combiner actually runs very important to understand, it runs locally on single mapper, it runs locally on the single mapper output, right? Because this mapper will be run on each and individual mapper and you can say that it always runs after mapper and before reducer, because it has to take the input from the mapper and it has to give the output to the reducer. That is why we can say it is optional, it is not necessary you need to opt, it is optional. And the most important thing about combiner function is, which we have discussed in the first class, that combiner function is actually an optimization technique, optimization function, or you can say approach, right? Approach or function or technique, this is there. Okay, so guys, any question in this or we can move forward? So it is giving you a little idea about what the combiner is. So any question, or are we good full and short works after combiner? You can say that, because if combiner is running, then we don't need that much of shuffle and sorting, because everything will be done at their part, right? And why I am saying that it runs after shuffle and sort, and very good question, because the combiner will work on the locally on the each and individual mapper where the output is in the local file system, the combiner will run over there, and after that shuffle and sort, one of the process of shuffle was that to travel the data from the mapper to the reducer. So that is why shuffle will be act later after this combiner, but the task of the shuffle will be very less. Okay, any other question, or we can move forward? So now let's understand from the diagram perspective. So if I draw a diagram, I can say that, if you remember the diagram, earlier diagram, we have a block 1 and then we have an input format, if you remember. Okay, then you have a mapper. Similarly, if I say there is a block 2 and then we have an input format and then you have a mapper 2 or mapper. Okay, now here we have a combiner, right? Now combiner, after combiner we have a partition, we are going to do in the next week. The partitioner is there, right? And then we have some shuffle, or you can say sort is there, and then the value will go to the reducer, and after that it will go to the record writer and something. Okay, so just I am writing record writer. So this is the same diagram, just want to emphasize the combiner, where the combiner comes. So let's understand from the difference perspective from the diagram. Let's say you have one mapper 1 is there, and cat comma 1 is there. Let's say cat comma 1 is there, and this cat comma 1 is coming 2000 times. Similarly, in mapper 2, cat comma is coming, let's say 1500 times. in mapper 3 cat comma 1 coming let us say 1000 times. So, total we are making it as a cat comma 4 is coming 2, 3, 4, 5 and let us say 500 times. So, total 5000. So, that means total 5000 cats are there and those are in different mapper. So, let us say we have few reducer. So, R1 is there, R2 is there. So, what happened in the normal scenario, all the data will travel from this to this, that means 2000 times cat will travel over here. Similarly, 1500 times cat will travel from here and 1000 time cat will travel from here, and fourth let us say we are understanding, sorry, problem is we either cat will move to one part. So, let us say it is going to the reducer 1. So, 1000 time cat will go there. Similarly, I hope you understand what I am trying to say is that means total 5000 record will transfer, but if we implement the combiner. So, what the combiner will do? It will do combiner, if you put a combiner over here, so the kind of aggregation which reducers will do, it will also aggregate over here, aggregate locally on mapper, each mapper, right. So, what it will do? It will give the result as a cat and comma 2000, right. Similarly, it will give a result cat comma 1500. So, this will be only one result. Try to understand what I am trying to say is, it is very important, cat comma 500. That means aggregation has been done. Now, the data will travel only this one. So, if this data will travel, that means one time, this data will travel only one time. Similarly, this data will be one time and similarly this data will be one time. So, only now instead of 5000 records to travel, now we have made it a 4 records, right. So, that combiner is very effective into that. Now, the important point is let us understand from the associative and operation perspective. So, now let us understand, I am just making it a sum of the reducer. What I am saying that some reducers may be used as combiner. That means what I am trying to say is some reducer can be used as a combiner if same time I am writing the if operation is your associative plus commutative. I think I wrote a wrong spelling last time, so please correct it. Okay. So, example is like your sum reducer. So, I just want to draw one simple diagram. Let us say there is a function called foo. So, in computer science we use this function very much. In Python you have seen this function. Okay. So, let us say we have a function called foo and the data is over here. Let us say randomly I am writing 2, 3, 5, 6. So, this data is there and then you are if the associative or commutative, it is not commutative and if it is commutative. So, let us say if it is commutative, what will happen if we do the sum part. So, now if we take sum and then we say 2 comma 3, it is one sum is going on, let us say this one, and other side it is going on sum comma 5 comma 6. So, now let us say there are 2 mapper and 2 combiner function you have implemented. So, what will happen when it aggregated, the answer will be like foo and then this answer will be 5 and this answer will be 11. Okay. So, now it means that now actual sum is happening is 5 plus thing is a 5 comma, or I can say, right, I am just writing in that scenario the function is sum 5 comma 11 and now actual result is your foo and 16 is answer, right. So, let us say answer is 16. Now, actually what happens, actually sum, if we do the sum part, it is 2 comma 3 comma 5 comma 6. So, now what is the result? Is the result should also be a 16. So, there is no problem if we segregate these two part or these two part separately. So, now if we now you can see that if the operation is commutative or an associative, what will happen, either you do 2 3 first time and then 5 6, the answer will be 16, and if we add all together, then answer will be 16. But in the other scenario, let us say if another scenario, if we have like some of the reducers, some you can say some reducers cannot be used as a combiner. So, in what scenario the reducers cannot be used as a combiner? That is why I wrote in the beginning that combiner may or may not be used as a reducer. The example we can say that average reducer. So, when we have an average reducer, we cannot use a combiner over here, and for this we can use this one. So, let us understand this also. So now I am again using the word called foo. So let's say, or let's make it another one. The very common one is a foo bar. So let's make a two different function. So let's say some random value I am writing 5, 5, 5, or you can say let's say 8 or 10. So these value I am writing. So now if we do the average part, so let's say do an average on first 3 part. So we do an average on 5, 5, 5, and another function as a combiner, you can say I am doing average on these two. Okay. So what will happen? The bar will say that average of this will be 5 and average of this will be 5 and average of this will be 9. Okay. So this is our bar results. Now, so what is the actual average? The actual average is your 5, 9, and then output is your bar, and if I add 5, 9, the average will be 7. But if we do the average over here, let's say average, and I am putting 5, 5, 5, 8, 10. So what will happen? The output will be over here. Answer will be your bar, and average will be 6.3. If you calculate 5, 5, 5, 8, so it will become 6.3. So that means there is a difference. So that is why, because that is why the combiner here cannot be used from the reducer, because the operations are not associative plus commutative. So this is the reason I just gave an example into that. We check the questions. Question was, for small data set, can we use combiner in place of reducer? No, you cannot replace. The most important part is we cannot replace the reducer. Reducer will be there only. Okay, so combiner will just to helping hand. So question was, can we use combiner in place of reducer? No, combiner will be a simple you can say optimization technique. You can add that. So till now we have discussed about what the combiner is, how it is an optimization technique, and different thing about the combiner we have discussed. So now let's talk about what are the different specification we need to give in terms of combiner. So I am just writing the combiner specifications, right? The first specification, we can say that just to define the combiner, we need to give that to the job class. So we need to write job dot set combiner class, and then we need to identify the class of the combiner name, and thus I am assuming that my combiner is similar to the reducer. So that is why I am using some reducer dot class, and this function is similar to that how we define in our word count problem about the how we can set the combiner, how we set the mapper and the reducer. Okay, so it means that combiner it is possible that the combiner may run, you can say combiner may run once, okay, or it can be run more than once also. Okay, so it can be more than once on the output, you can say given, you can say output from the, so you can say output from the given mapper. Okay, so it can run twice also, it's not a problem, but usually we run this combiner function once. Okay, if we are using the combiner function. Okay, now what happens, we don't actually put the code in the combiner, right? So this is very, very important to understand that we don't put the code in the combiner. Actually that influence results if runs more than once. So that means if we execute the combiner function more than once, and if the results are different, results can be changed. Okay, if we do the sum part, then if we execute more than once, then it is not a problem. But for certain logic, if we if this more than once execution of the combiner is actually changing the results or doing some kind of integrity, or it can influencing the result, then we should avoid this kind of logic for the combiner. So in that scenario we won't use the combiner. Okay, so always believe that this combiner actually, you can say, does not replacing your reducer function. Okay, it is not it is not actually replacing the reduce function. It internally actually it is helping, it means it helps to reduce the amount of data shuffle. Okay, that means and the shuffling happens between the mapper and reducer. So we have just saw that how the data shuffles from the mapper and the reducer, and when we implement the combiner, what happens, it reduces the amount of like a data to traverse. That also results in the network congestion also, right. So now this is a very few specification about the combiner. So let's talk about the few advantages and disadvantages about the combiner, and which you have already seen during when we have done, but I want to put into the some way so that you can remember that. So what is the advantage of the combiner? So that means if you use a combiner, that means it reduces the time. The combiner reduces the time taken for data transfer. Okay, so time taken for data transfer between your, you can say, mapper and reducer, right. So this will, the important point is time taken, right. The another advantage of using the combiner is that it decreases the amount of data needed to be processed by the reducer, right. So that means the amount of data, it also work on that. And you can also that the combiner actually improve the overall performance of the reducer, right. The overall performance of the reducer, and you can say that it also decrease the or reduce the network congestions. And if you see, this fourth point is actually come up from the second point itself, right. So this is the few advantage of this one. Now let's talk about the disadvantage and disadvantage. What can be a disadvantage for the reducer, right. So what happens, like your map reduce jobs cannot cannot depends on completely on the combiner. Okay, so they cannot completely depend on the combiner, because why? Because there is no guarantee. There is no guarantee in its execution, because it is depend on that either we are taking or not, we are using this combiner or not, right. So what happens in the actually local file system, what happens, the key values are stored. Okay, the key values are stored in your Hadoop ecosystem, right. So in case suppose in Hadoop ecosystem, some of the files are stored in local file system, that means in your hard disk, and then if you run combiner, let's say if you run combiner on the local file system, then it causes a very expensive disk IO. So earlier it was in the Hadoop, then it was okay, but in case if we have to take data from IO, because if we execute the mapper twice, then what will happen, the data will be processed from the reducer from the Hadoop, that means processed from the HDFS, and then it will be stored the data locally into the local file system LFS. Then if you execute the mapper twice, then in that scenario it is possible that the data from the local file system has to be taken care by the combiner, and then that it become a very little, and then it become a very expensive disk IO operation. Okay, so I am just writing as an operation also, the disk IO operation. This is the small, you can say, drawbacks of the reducer. So now let's see important part. This is the first time we are introducing that. Let's talk about a little configuration file. Okay, so just I am talking about the configuration file in the MapReduce, and then I am putting the name of the configuration file is your MapRed hyphen, this is hyphen site.xml. So this is your first configuration file. Okay, so what happens, this configuration file is actually stored in your /etc folder of the Hadoop ecosystem, right. And This configuration file actually contains all the configuration information related to your MapReduce, right. Okay. So, now let us see few of the configuration. So, let us see few of the configuration that I am talking about. The first configuration is like, let us say, because it is a XML file, then there will be lot of naming conventions or nomenclatures will be there, lot of properties will be there for this configuration. So, we will see few of the important properties, and if you want to see in all the properties, better you open this, you can go and see this mapred-site.xml. So, let us see few of the important property which one should know. Okay. The first property is MapReduce dot framework dot your name. So, that means I am putting the name of the framework. Okay. So, in our case, because after this class we are going to understand the Yarn framework yet another. So, just I am putting the name of the framework is Yarn or MapReduce, right. So, this is the name of the framework. Second is your MapReduce dot map, this is about the mapper part, and then memory, and then MB. So, this is very simple to understand, and then the default value is 1024 bytes, right. So, this is 1024 bytes, and this is actually a, you can give a large resource limit for that. You can give a large, resource limits for your mappers. Okay. So, you can increase or decrease this part. Third is again is your MapReduce. So, this is very easy to understand, that always you need to write MapReduce, and then instead of map I am using the reduce, and then memory and dot MB. So, now the default is 370. Okay. Now, again you can put for the last limit for the reducers, right. Fourth property is about the sorting. So, now you can say that MapReduce dot, you can say different task we have dot IO, and then we have sorting as a sort, and then the memory we are going to use, and default is 512. Okay. So, that means here what you can do, you can have a higher memory limit. Okay. So, higher memory limit you can use while sorting your data for efficiency. So, it is depends upon your scenario, use case, how you want to put. So, if we add one more property in the configuration file, that is again a MapReduce dot, you can say map dot java dot opts. So, this is options, right. So, when I say option, this the default size is actually called XMX 1024. So, what is XMS is basically this is the property basically used for the, like say, larger heap size. Okay. So, larger heap size for your you can say child JVMs of your mappers. Okay. So, this is about the mapper, and this is about the heap size. As you have already know about the Java uses a heap for storing the object. So, that is my in between intermediate space for the heap also you can specify, so that your system can be fast. And whenever we use a heap, you will always see XMS tags into that, right. This is your M, this is your M you need to add. Similarly, for heap size for reducer, so you can say MapReduce, instead of map now we have a reduce. So, now we have a reduce dot java dot opts. Okay. And the default size is 2560 M. Here you can see that always reducer is having a larger size or space. Why? Because that means again larger heap size for your child JVMs for the reducers. Okay. So, map and mapper you can interchange, I am using this word for this one. So, JVM for the reducers. So, because mapper are more than the reducer usually, so that is why reducer are less, that is why it gives a more space to that, right. So, now one more property just I want to add again about the MapReduce dot you can say reduce dot shuffle dot parallel dot size copies, parallel dot I think there should be parallel copies, I think parallel copies or parallel, okay, parallel copies, let us understand that way. and then default size is 50, right. So, this is actually about the parallel copies run by reducers. Now, important point to note over here, that here shuffling is connected with the reducer, and then we discussed that this shuffling is also a one of the part or one of the phase of the reducer, right. So, that is why this the property comes under reducer dot shuffling dot parallel copies, right. So, this is a very high level idea about the configuration file map reduce map read dot hyphen site dot xml.